Here we go with page 2, question 8-38. Use your knowledge of polygons to answer the questions below, if possible. Oh boy, maybe there's some we can't answer. What I want you to do, I really encourage you to try these problems on your own before you rip through the video, because I think many of these you should be able to solve without kind of me showing you how to do it. All right, part A. How many sides does a polygon have if the sum of the measures of the interior angles is 1,980 degrees? Notice here, we're not talking about a regular polygon anymore. It just says a polygon, so I cannot assume that all the angle measures are the same. It just so happens that in this problem, I don't need to do that. I know that the sum of the interior angles for all polygons, doesn't matter if they're regular or not, is equal to 180 times n minus 2. Now, if that is equal to 1,980, and I want to solve for n, the first thing I'm going to do is divide both sides by 180. And that's going to give me n minus 2 equals 11. 1980 divided by 180 is 11. I'm going to add 2 to both sides, and I get n equals 3 sides. So if someone says, hey, sum of all the angles of this polygon is 1,980, 1980, it was a pretty good year, by the way, then you know that thing has not 3 sides, 13 sides. Okay, let's now look at 900. Again, if we have that formula for the sum of the interior angles, it's 180 times the quantity n minus 2. If that equals 900 and we want to solve for n, we're going to divide out by 180. I'm left with n minus 2 on the left, and 900 divided by 180 is 5. I'm going to add 2 to both sides, and I'm going to get 7. Again, if somebody says, hey, you got a polygon where all the interior angles add up to 900. How many sides does it have? You're going to say 7. Great. Let's move on. Part B. If the exterior angle of a regular, we're back to a regular polygon again. That means all the interior angles are the same, all the exterior angles are the same. If the exterior angle of a regular polygon is 90 degrees, how many sides does it have? What is another name for this shape? So let's use that strategy of trying to sketch it again. So I'm going to sketch some sides of a polygon here, and then we'll show that it's kind of cut off. And then I have this exterior angle here, which I'm told is 90 degrees. Well, if that's 90 degrees, then this also has to be 90 degrees. If it's a regular polygon and the interior angle is 90 and all the sides are the same, it's going to have to look like this, folks. And last time I checked, the name of that bad boy is a square. Okay, I didn't even need a formula for that one. Okay, I could just reason through that one based on what I know about interior and exterior angles. Remember, they have to add up to 180. And then if it's a regular polygon, all those interior angles have to be the same. If you were to look at a formula for that problem, you'd probably look at this one. The measure of an exterior angle for a regular polygon is 360 divided by n. So that means 90 equals 360 divided by n. And we use that same strategy we've used before of kind of swapping the diagonals. We then have n equals 360 over 90. So that's 4 sides. And we know a 4-sided regular polygon is called a square. All right, folks, we are making serious tracks here. Let's move down to part C. Each interior angle of a regular pentagon has a measure of 2x plus 4 degrees. What is x? So a regular pentagon, I'm going to do my best to try to sketch this bad boy. These are not the easiest thing in the world to sketch. Pentagon, 5 sides. That's not too bad. Could be a little better. And then each interior angle is 2x plus 4 degrees. Okay, and we have to find out what x is. Well, let's go ahead and find out what the sum of all of the interior angles it is, using our friend 180 times n minus 2. So So that's 180 times 5 minus 2, or 180 times 3, which is, that's 540 degrees. And I know I have 5 of those angles, so each interior angle, because it's a regular polygon, they'll all be the same. It's going to be 540 divided by 5, and that's 108 degrees. So that means this angle right here has to be 108 degrees. So let's just set up a simple algebraic equation to solve for that. 108 equals 2x plus 4. I'm going to subtract 4 from both sides. That gives me 104 equals 2x. I'm going to divide both sides by 2, and I get x equals 52 degrees. Can of corn. All right, let's move on. Part D. So the measures of 4 exterior angles of a pentagon, so we have n equals 5, but now we're talking about exterior angles, and there's 4 of them, 57, 74, 56, and 66. What happened to the 5th one? Well, that's what we have to do. We have to find the measure of the 5th angle. So we know that the sum of the exterior angles is always 360. Doesn't matter if it's a regular polygon or not. So that has to equal the 57 plus the 74 plus the 56 plus the 66 plus that last 5th exterior angle, which we don't know. Let's combine like terms on the right hand side. You add those numbers up, you get 253 degrees. Now let's subtract 253 from both sides, and we get 107 degrees is that last exterior angle of this pentagon. Hey, guess what? Last one. Find the sum of the interior angles of an 11-gon. Does it matter if it's regular or not? The answer is no, it doesn't matter, because we've been using this formula for 2 lessons now. Sum of the interior angles is 180 times n minus 2. So that's 180 times 11 minus 2. That's 180 times 9, which is 1620. Boom. That's it, folks. Congratulations, you just finished lesson 8.1.4. Please, for the love of all that is geometric, look at the review preview problems. Thank you, and good night.